Hello, this is Gaurav Bamula, and this is our DSP lab, Experiment 1, Lab 2. In this lab, we'll be doing the same filters. We'll do 4 types of filter, and this time we'll use a PPG sensor to collect the real-time data and perform signal processing on that data. So this here is a basic diagram of a PPG sensor. PPG sensor is used to calculate the pulse rate of it stands for photophlebotogram. How PPG works is PPG makes use of low intensity infrared light, green light. When it travels through biological tissues, it is absorbed by bone, skin pigments, and both veins and arteries. Since light is more strongly absorbed by blood rather than surrounding tissue, the changes in blood flow can be detected by the PPG sensor as change in intensity of light. Hence, PPG sensor is used to measure the blood flow. So this is our first moving average filter. So here we have used a variable sensor value. It will store the values from the sensor. It will be our input from the sensor. We'll store it in this variable called sensor value. Y will be our output from the filter. So the only addition that we did from last week is that we added this snippet of code, that is sensor value I equal to analog read a naught. A naught is the port in our Arduino board that the sensor is connected to. uh, this line of code will store the value that the board will read at the port a naught to the sensor value I, and then we delay by 10 milliseconds so as to collect the next value, and we implement this code to get the input from the sensor to our variable sensor value. The rest of the code is same as last week. It is a regular moving average filter. So we'll plot it now. So this is the plot. We can see the red line is the moving average, is our output after moving using moving average filter, and the blue one is our input from the sensor. We can see that our output is way more smoother than our input, and this is why we used moving average filter. So moving on. So here in the second part, we will use a derivative filter. So we did the same thing. We took the input from the signal, and then we implemented a derivative filter. This is the same as the last week. I'll put the link of the video from the last week in description if you want to know about the sensor in much more detail. So now let's plot this derivative filter. So here we can see the derivative filter. Uh, for the third part, we have to design a moving average filter whose the length of the filter will depend on n. That is, L will be equal to 0.8 into n. This will extract the baseline drift component from the signal. So this is our code implementing this filter. Here again we took the input from the sensor, and then we put the length of the moving average filter at 0.8 into 250. 250 is a sample size. This is how many samples of the input signal that we have. So our length of our moving average filter will depend on the length of our moving average filter will depend on this our sample size. So again we implemented a moving average filter using this length. So now let's plot this. So we can see here the output signal. Here we are extracting the drift component of the signal. So we can see here we'll extract a baseline drift component from the signal using a moving average filter whose length depends on the sample rate. For our final filter, we have to design a signal processing system which performs derivative filter and then performs a moving average filter with length n equal to 8. So this is our code implementing this filter. So again here we took sensor value, it will store the input from the sensor. Then y will store a derivative filter, and z will store will be the moving average filter after on the derivative filter. So again we took the input from the sensor with a delay of 10 milliseconds. Now L equal to 8, we initialize the length of the moving average filter as 8. Now we in this line of code we uh, we implement a derivative filter on the sensor value, and yi will be a variable which will store this derivative filters will be our output signal. Mm, Now again we'll implement moving average filter on this on yi. So zi will be the variable, will be a output of the moving average filter, and it will take yi, that is the derivative filter of the sensor value, as the input of the moving average filter with length equal to 8. So this is a implementation of the moving average filter on y of I. If you want to know more in details about moving average filter and derivative filter, I'll link the last video in the description. And then we plot everything. We plot the sensor value, that is the input from the sensor. We plot the derivative filter with the 200-degree vertical shift, and we plot the moving average filter, our final output. So we'll now upload this. So we're done uploading now. So now I'll plot this. So here is our output. The red signal is our original input signal. The green signal is a derivative filter of the input signal, and the blue signal is a moving average filter of the derivative filter of our original signal. So you can see the graph. We can see that the blue it is hanging a bit, but we can see the blue filter is much more smoother uh, than any of the other two filters. So this was our experiment 1 of the DSP lab. We implemented these 4 types of signal, and we learned how to take input from a sensor, and to use the data from the sensor and filter that data and process that data. So this will be the end of our experiment. Thank you.